MatchBox from Hitomi is a custom piece of hardware which is used mostly in the live environment to measure timing for live broadcasts. It can measure audio to audio timing, video to video timing, and audio to video timing, which is lip sync. In addition to that, we can also measure latency in any path that you choose to measure. The way it works, when the circle gets to the 12 o'clock position, you'll see there is a black flash in 2 dimensions. That is a marker in the video. That's the start point of a sequence. It takes precisely 4 seconds for the circle to make 1 revolution. The colors that you see on the circle correspond to test tones in the audio. The position of the tones that go from the generator are absolutely known and fixed and precise. It's a 2-part solution. A perfectly timed test pattern is launched at one end. It then goes through what you're trying to measure, and at the other end you have our analyzer, which is looking and listening for that perfectly timed test pattern. The difference between what it sees and what it's expecting is the measurement. Here we have the analyzer output, which is a completely live picture. When it hears a test tone, it puts a square up to show that it's heard. This is a 5.1 surround sound sequence where we've got 16 channels of embedded audio. In this particular set of channels, it's 5.1 stereo. If there was any phase coherence here between the difference, we would know. It would come up here, any difference in samples. This actually happens to be straight on. Lip sync is measured by this green bar here. We've simulated 17.5 milliseconds of delay on the video, so that the audio is actually ahead. If audio was late, it would be this side of the bar, but the audio is early, so it's that side of the bar. Green means that the lip sync is okay to go on air. Nobody's going to really notice 17.5 milliseconds. But if it was to go over 20, then trained ears would probably say, there's something wrong with that. And that's the yellow region. The red region is when everybody would notice, and it really must be fixed. So it's a simple visual cue for operators when they're looking at the system. This QR code here has got the time of day in it, and that's how we measure latency. The QR code is sent from the generator, which knows its time from either an NTP or a PTP server. Similarly, the analyzer has got its own internal clock, and it simply compares its accurate time of day with the accurate time of day that it's been given in the QR code. That gives us latency to 0.1 of a millisecond. See channel 3, that's exactly 1 frame. That's from the generator to the analyzer. We've done that deliberately to show that it's a precise measurement. The graphical user interface is available to engineers. What you see here is probably what people would look at in the master control room. All the idents can be changed, and then here you've got more engineering information should you need it. There's more information about this on our website. This is just a short introduction.